Hello, I'm here to talk about calorimetry, which is the process of measuring the heat transferred in a chemical reaction or a physical change. However, in this class, we deal specifically with chemical reactions. Calorimetry requires a calorimeter to measure the heat change over the progression of the reaction and an insulated container, like this coffee cup here, to minimize the heat loss to the surroundings that won't be measured by the calorimeter, which measures the heat change of the solution. It is important to keep factors such as pressure and volume constant to evaluate the heat change independently. And we use this process in experiment 2 to evaluate whether a reaction was endothermic or exothermic and track the progression of the chemical reaction. This is important for synthesizing chemicals as it is critical to know when a reaction has fully occurred. But calorimetry has uses beyond just in a college chemistry lab. For example, the calorie counts on food labels, such as this one, calculated by burning foods and measuring the resulting heat transfer to water. This is calorimetry. But how does calorimetry really work? We know chemical reactions absorb or release heat, but where does this come from? When chemical bonds are formed, energy is required, and the opposite is true for when bonds are broken. This heat released or absorbed in a reaction is referred to as enthalpy, and enthalpy is a state function, meaning that the result is the same regardless of the path taken to get there. Species have heats of formation, which are the heat absorbed or released to when a single mole of a substance is formed. Enthalpy for a reaction can be calculated by subtracting the enthalpies of formation of the reactants, multiplied by the correct quantity of moles, from the enthalpies of formation of the products, multiplied by the correct quantity of moles. And that gives you the heat change of the reaction. Now, it is important when dealing with chemicals to keep safety in mind and wear the proper PPE and rinse containers after use to prevent any unplanned reactions. Also, a stir bar is a great tool for improving the efficiency of this process by decreasing the time it takes for the reaction to occur. A catalyst is another good option for this. Thank you.